So this is the final set of integration formulas that we will learn. This one involving the natural logarithmic function, which is just y equals ln of x. Na-meet na natin yan before. Tapos, si exponential function also, which is y equals e raised to x kung natural exponential function tayo. Or in general, y equals b raised to x siya with some conditions kay b kung yung general na exponential function. So, yun ang matututunan natin today. Ano yung mga integrals involving when. Alright, so let's start. Okay, so before we give the actual formulas, siguro let's try to derive kung paano siya nakuha. No? So, dun muna tayo dun sa ln, sa natural logarithmic function. Recall natin quickly ang power rule for integration, which is given by this one. It involves this integral of x raised to n dx. Okay, na yung formula ay given by this, x raised to n plus 1 over n plus 1. There's a plus c because this is an indefinite integral. Now, recall, itong power rule na ito ay in fact nag-work lamang for any n, actually, any real number except for n equals -1, hindi siya mag-work. So, yung natural question from that is, paano kung n nga is equal to -1? Ano yung integral nun? No? So, pwede pa rin naman nating hanapin yun. Okay. But, hindi na yung formula na ito yung gagamitin natin. No? So, yun yung matututunan natin ngayon. Kung ano yung integral nun. So, that is, what is the integral of x raised to -1 dx? Or rewriting that, what is the integral of 1 over x dx? But before we answer this, let us recall the derivative of the natural logarithmic function as follows. So dito, ang paparecall ko sa inyo, sana ay yung ln absolute value of x. In general, ang natural logarithmic function natin ay ln of x lang. Pero recall quickly na ang domain ng ating ln of x ay only positive real numbers. Hindi siya valid or hindi siya defined for 0 and negative numbers. Pero kapag itong derivative formula yung kinonsider natin, dahil sa absolute value, it can already take in negative numbers. So that yung ln safe, yung mga tinitake niya ay positive because of the absolute value. Now from before, alam natin, I just simply equal to 1 over x. Okay, so bakit ko ito pinarecall? Kasi dito actually manggagaling ang ating integral formula para masagot itong question na ito. Kasi ang derivative ay isang reverse operation lang ng integration. So integrating both sides, sulatan ko siya, integral ng 1 over x dx. We do that also to the other side and this one cancels out. So ang corresponding na formula natin ay ito po. Ang integral ng 1 over x dx ay equal sa ln absolute value of x plus c. Yeah, so yung next slide ay summary lang nung na-discuss natin. Dito though, u na yung ginagamit na parang variable, where yung u mo dito can be some differentiable function of x this time. Kasi hindi naman all the time na parang stand-alone na x lang yung nasa integrand mo eh. Pwedeng some function in x. So pag ganun, ang ginagawa natin ay nagle-let u tayo to be equal to that function in x. Tapos, nagiging valid pa rin yung formula natin. Where, recall lang natin, yung du dito medyo iba siya. Ito ay yung differential of u natin. So, recall ko lang quickly kung ang u natin ay f of x, which is differentiable. Then, yung differential of x natin ay dx. And yung differential of u natin, which is this one actually, du, has the formula f prime of x dx. Sige, to illustrate this theorem, let's try. Number 1, we are to evaluate the integral of 3x cubed minus 4x plus 2 over x dx. Usual technique ang u substitution. So siguro, try nating mag-u substitution. Ano ba yung mga quantities na pwedeng ilet as u dito? Well, you have your numerator. Okay, so try lang. Baka mag-work. Try natin. Pag u natin yung numerator, ano ang ating du? Again, from the formula sa last slide, siya ay 9x squared minus 4. And of course, don't forget the dx, and you multiply the dx to the whole f prime of x. Okay, and then sa u sub natin, u substitution natin, ang purpose kasi nun ay para ma-simplify si integrand. So, kung kaya sana na meron kang expressions na ganito sa integrand mo, ma-absorb na siya ni du as long as masusulat mo yung mga quantities here sa integrand in terms of u. Although dito, unfortunately, walang 9x squared minus 4dx. So actually, pangungunahan ko na kayo, hindi ito yung tamang solution. Usual rin naman na candidate as u yung denominator. Kasi for this particular example, ang denominator natin ay x lang din. And yun din, sabihin ko na rin, kapag tinake nyo as u yung x, ang mangyayari ay du equals dx lang rin, pinalitan nyo lang yung mga x as u. Well, hindi u sub yung gagamitin natin dito. Different technique ang gagamitin natin. And ano yung technique na yun? Ang pwede natin gawin para ma-simplify ay i-distribute ang denominator among the terms sa ating numerator. So let's try that. Doing that, ito, dinistribute ko yung x at dinivide ko sa bawat term ng numerator ko. And simplifying, what I get is this integrand. So, see na mula dun sa given na medyo complicated pa siya, medyo na simplify naman natin yung integrand. So, integrate natin one by one yung mga terms. Let's go to 3x squared first. Ang integral ng 3x squared from the power rule na integration formula lang rin natin kanina. Yung x squared, ang integral ay x cubed over 3. Multiply that to the constant factor na 3 kasi sa integration, kapag may constant, lumalabas lang siya sa integral natin. So therefore, the integral of the first term is this one, x cubed. Next tayo, dun sa negative 4, ang integral nito kapag constant ay, well, lalabas yung negative 4, tapos matitira yung integral ng dx. And ang integral ng dx, recall, ay x. So therefore, yung next term natin ay negative 4x. And then, ito na yung natutunan natin just now, ang integral ng 2 over x dx. Okay. Yung 2, again, ay lalabas lang sa integral. So that's 2 integral ng 1 over x dx. That is just ln absolute value of x. Kaya, ang ating integral ng 2 over x ay precisely 2 times ln absolute value of x. And of course, this is an indefinite integral, kaya wag rin kalimutan ang ating friend plus c. And that's our final answer. Next tayo. Alright, next one. I-evaluate natin this time ang integral ng tangent x, one of our 6 circular functions, no, si tangent x. So para lang ma-recall, may mga natutunan na tayong integrals ng some trigonometric functions as follows. So yan ang ating mga formula for the integrals of trigonometric functions. But gusto ko lang rin ma-notice natin na, well, walang tangent x dito, no? Hindi natin alam ang integral ng tangent x so far. And actually, the way to look for this, kakailanganin natin yung theorem, yung formula na natutunan lang natin just now. So let's see, i-illustrate natin yun. So actually, yung technique for this one is to rewrite tangent x as follows. Sin x over cosine x ang ating tangent x. So dito, meron ng sin x at meron ng cosine x. And ito actually ang gagamitan natin ng u sub. Okay. Yun lang nga, ano yung gagamitan nating u dito, sin ba o cosine? Well, Pag nag-let u ka nung sign, ang du mo ay ano po, cosine x dx, where cosine x is multiplied to dx. Eh dito naka-divide ang cosine x natin eh. So baka hindi yun mag-work. Baka yung u equals cosine x ang mag-work actually. And in fact, yun yung mag-work. So pakita natin yun. If nilet ko ang aking cosine x to be u, my du therefore is negative sine x and then dx. Where itong sine x dx ay andito sa ating integral. And so therefore, maa-absorb siya actually ng du at masisimplify ang ating integrand, which is our goal kapag nag-u sub eh. Yeah, there is just this negative here na dito sa ating integrand hindi pa siya outright nandyan. But that's okay. Itong negative na to, pwede natin siyang paglaruan at i-divide sa ating du here. Para sin x dx lang talaga yung nag-a-appear. So doing that, we have this. Okay, so again, sin x dx ay maa-absorb ng negative du. I-rearrange ko lang ang mga factors natin para kita ang sin x dx. Rewrite na natin ang ating integrand in terms of u. So again, si sin x dx ay magiging negative du. Ang cosine x naman natin ay magiging u. So rewriting that all in terms of u, we have this integrand. Ilabas lang natin yung negative para mas madaling i-integrate. So here, nandito na ang ating formula. Ang integral ng 1 over u du ay precisely equal to negative ln absolute value of u. Don't forget our plus c. Ayun, so actually ito yung sinabi ko dun sa previous slide na there are times when your u is not an x na standalone but a differentiable function in x. Sa case na to, yun ay naging si cosine x. Kailangan sa inyong final answer, ibabalik nyo kung ano yung nilet nyo as u. So dito, cosine x, kaya dapat ang final answer natin ay ito. Negative ln absolute value cosine x plus c. So wag niyo yun kalimutan no, sa exam or kapag lumabas sa exercises, ganon. Ibalik nyo dun sa kung ano yung original na variable. Paano nyo yun ma-check? Balikan nyo lang yung original na given sa inyo. Kung ano yung original na variable na ginamit doon, in this case, x, yun din dapat yung variable na naka-involve dun sa final answer. So note rin pala natin, by the way, na ang negative ln absolute value of cosine x ay pwede nating ma-rewrite using properties of the natural logarithmic function. Pwede natin siyang ma-rewrite this way. So this is the absolute value of cosine x raised to negative 1. Pag naka-negative 1, it means iti-take natin yung reciprocal ng absolute value cosine x. Therefore, this is what we have. It turns out na ang integral ng tangent x dx ay ln absolute value of secant x plus c. Alright, so kaya-kaya, no? Itong example na ito. Let's proceed to the next one. Alright, so here we have example 3, still an integral, but this time, definite na. Meron na tayong bounds of integration. Meron tayong limits of integration. So, pag nakuha na natin yung sagot dito sa integral, ipapasok lang natin yung bounds dun sa function na makukuha natin sa pag-solve ng integral. At ang sagot natin ay isang legit value. So again, a usual technique is u substitution. So siguro yung gawin natin muna here. Maybe let's try the denominator. So what happens if we try to let u be the denominator? In this case, x squared plus 1. Ano po ang ating du kung ganun? Okay, so f prime of x lang natin, differentiate, we get 2x times dx. Na actually, this one is a safe du. Kasi nandito sa ating integrand, yung x dx. Meron nga lang 2 na kayang-kaya nating ma-remedy. Pwede rin nating i-divide si 2 kay du. Para x dx lang ang mag-appear at yung du over 2 na yung ilalagay natin dito para everything becomes in terms of. Okay, so balikan natin itong given. Sa given natin, ang bounds or limits of integration natin ay 0 and 1. But that 0 to 1 is actually in terms of x based on the variable na nakalagay here. No? But if we want to change the variable in our integrand to be u, kailangan consistent din na yung mga bounds natin ay in terms of u also. If our x is equal to 0 here, simulan natin dun sa lower bound of integration, then our u, based on our definition for it, ay magiging 0 squared plus 1 na equal to 1. Ano naman yung upper bound of integration therefore? If ang x natin ay equal to 1, basing it on our definition for u, ang new upper bound of integration natin ay magiging 1 squared plus 1 equal to alright, so rewriting everything in terms of u, ang bounds natin for integration this time ay magiging 1 to 2 na, and then our integrand naman will become 1 over ang x squared plus 1 natin ay u, so that is 1 over u, times ang x dx natin ay equal sa du over 2. So that's u over 2. So therefore, our integral is rewritten in terms of u na this time. Rewrite lang natin everything here. Yung mga pwedeng ilabas, si 1/2 ay pwedeng ilabas kasi constant lang siya. And dito na lang tayo mag-work kay 1 over u du. Siya ay magiging ln, absolute value of u. Here though, wala nang plus c. This notation just means that we are evaluating the function here, which is 1/2 ln absolute value of u from 1 to 2. Recall natin, nagsisimula tayo dun sa upper limit of integration and we substitute that into our variable u. And then the formula goes minus yung same function, but this time substituted na ang lower bound of integration natin. So therefore, equal siya dito. Ito, ang ln of 1 natin ay equal sa 0. So actually, this cancels out. And so therefore, our final answer is this one. ln of 2 over 2. Next tayo, one last example for this particular theorem. Alright, so here we are to evaluate yet another definite integral, given by this one here. My other tip for you to use as u, okay, is yung mga inner functions na nakikita ninyo sa ating integral. See here that ln of x ay naka-raise sa 2. So we can actually interpret this na nakakompose ang ln of x sa loob ng x squared. Maybe let's try ln of x. Let's see. So if we let u be ln of x, ano ang ating du is 1 over x and then multiply that with dx. So tingnan natin yung 1 over x dx ba ay nandito? In fact, yes, no? Andito siya. So yes, yung mga yan ay maa-absorb lamang ng du. Ang ln of x natin ay magiging u. So actually, dapat i-rewrite pa ang ating mga bounds for integration in terms of u. So kapag ang x natin ay equal sa e, sinimulan niya sa lower bound, from our definition for u, ano na ang ating u? It will be equal to ln of e, and that is equal to 1. And then our upper bound of integration, si e squared, kung yan ang ating x, then ang u natin, using this definition for u, ay magiging ln e squared. So therefore, 2 ang ating upper bound of integration in terms of u. So rewriting our given, ang bagong bounds na natin ay from 1 to 2 in terms of u na. And our integrand will become 1 over u squared, kasi nilet natin as u yung ln of x. And then, ang 1 over x dx ay absorb na yan ng du. Okay? Do not be fooled. Baka sabihin nyo, ay, 1 over u squared. Sige, rewrite ko to as 1 over u quantity squared. Tapos, okay, yung 1 over u, ln absolute value of u, tapos isa-square ko na lang. Hindi tama yun, no? Yung tamang way to solve for this, okay, is to rewrite it as follows. Write natin as u raised to negative 2. So, power rule ang gagamitin natin dito. Ang integral ng u raised to negative 2 mula sa power rule ay this. And then, our goal here is to look for a legit value. Okay? So, pasok lang natin ang ating bounds. Okay, so this is negative 2 raised to negative 1 or negative 1 half minus, okay, by the formula, negative 1 raised to negative 1, kaya negative 1 lang ito. So therefore, our final answer is 1 half. Let's proceed ngayon. So tapos na tayo sa natural logarithmic function. Let's go now to the exponential function. So let's see. Recall natin ang derivative muna ng e raised to x. Special tong e raised to x kasi in fact, ang derivative niya ay sarili lamang niya, e raised to x. Then, yung for the more general exponential function b, yung b na yan can stand for any positive number, pero hindi natin kinoconsider yung 1. Ano ang ating derivative ulit before? Sana naaalala, it is equal to b raised to x times the value, the constant, ln of b. Mula dito natin i-derive ang mga integral formulas ng e raised to x at b raised to x. Like what we did lang rin dun sa involving the natural logarithmic function, i-integrate lang natin both sides ng equation na ito para ma-cancel out ang derivative at makuha natin ang integral. So let's do that here. Let us integrate this one first. Ayan, i-integrate ko na. Of course, we do that to the other side. So these cancel. Actually, na-derive na natin yung unang integral formula natin. Ayan. Ang integral ng e raised to x dx ay equal sa e raised to x lang rin. So, special talaga si e raised to x kasi yung derivative niya, sarili lang niya. At na-discover natin ngayon, ang integral niya ay sarili lang niya rin. No? Let's see naman yung b raised to x. Ito medyo may slight modification. So, integrating both sides, yung equation na ito, we have the integral of b raised to x ln of b dx. And then magka-cancel again tong d over dx natin as before. But our goal here, by the way, is to get the integral of b raised to x dx. So, itong constant na to, pwede nating ilipat sa other side ng equation actually. So, dividing both sides by ln of b, magkakaroon ako dito na b raised to x over ln of b. So, yun. Ang ating b raised to x dx integral nun ay b raised to x over ln of b plus c. So, ito yung ating mga integral formulas. Okay. So, itong next slide ay sinummarize lang yung integral formulas from the previous slide. Pero again, dito in terms of u siya, it can be some differentiable function in x. Ang du natin ay magiging equal to f prime of x dx. Meron pang additional step na yun. Okay, so let's illustrate these formulas through examples. We have here example 5. We are to integrate x times e raised to x squared dx. Okay, attempt tayo ng u. Ano po kaya ang pwedeng ilet as u dito? Again, yung mga inner functions. And dito, if you analyze, si x squared ay actually nakakompose sa loob ng e raised to x. Let's try si x squared. And I think that will work. Let's let u be x squared. If ganon, ano ang ating du? Then ang du natin ay 2x dx, f prime of x dx lamang. And like what we did in the previous example, ang meron ka kasi dito sa integral ay x dx. So para ma-force na x dx lang ito, itong 2 na ito, constant lang naman siya, pwede natin siyang ilipat dun sa kabila at i-divide kay du. So therefore, ang du over 2 natin ay equal sa x dx. And then, ito na, rewriting everything in terms of u. We get e raised to u, kasi ang definition natin for u ay si x squared. Ang x dx naman natin absorbed by du over 2. The du over 2 here is just 1/2 times du, and the 1/2 is a constant that can go out of our integral. So 1/2 to times integral ng e raised to u du. So yun ay 1/2 e raised to u. Don't forget, ito ay isang indefinite integral kaya merong plus e. And then again, huwag rin kalimutan, our original variable in the given is x. So we will have to bring back the original definition for u in terms of x. So ang final answer natin ay ito po, 1/2 e raised to x squared plus c. Ito ang ating final answer. Okay, next. So now we are to integrate 10 raised to 5x dx. Usual technique, u substitution. Ano kaya ang pwedeng u? Parang isa lang naman yata ang pwedeng u dito, no? Ang inner function natin dito ay si 5x. Nakakompose siya sa loob ni 10 raised to x. So, sige, si 5x na lang siguro. Ano kayang mangyayari kapag nalet u natin ang 5x? Ang du natin ay simple lamang magiging 5 dx. Where this 5, because of it being a constant, pwede lang natin siyang ilipat just the same like how we did in sa previous. So, we have du over 5 equal to dx. And then, rewrite lang natin si integral natin all in terms of u. Dx will be changed to be du over 5, and 5x will be changed to be u. And safe na tayo, puro u na lahat. Okay? Tapos yung du over 5 ay 1/5 times du lamang. So the 1/5 goes out of our integral. And so we get integral of 10 raised to u du. And ano ang ating integral for 10 raised to u? Here, open formula pa tayo. Ang integral ng 10 raised to u ay given by this one, where of course our b is 10. Kaya, using this formula, we have 1/5, okay, times 10 raised to u over ln of 10. And then, indefinite integral, don't forget your plus c. So almost the final answer, we just have to bring back the original definition of u in terms of x. Kasi yun yung original na variable here. So that is our final answer. The next 4 examples natin ay medyo slightly more difficult. Mara-run through na rin natin yung mga usual techniques sa integration. So let's see. Ano kaya yung mga yon? Evaluate naman natin to this time. Integral of e raised to x times 1 plus 3 raised to x. Attempt lang natin, okay? Pag ang u natin ay e raised to x, ano ang ating du? E raised to x lang rin times the differential of x dx. Well, e raised to x dx is here, so ma-absorb siya ng du. Pero si 3 raised to x, medyo mahirap siyang i-rewrite in terms of u sad face. Kasi baka hindi ito mag-work or baka matagalan kung ito yung in-attempt ninyo. So let's try a different u. Pag ang u natin ay 1 plus 3 raised to x, ano ang ating du? 3 raised to x times ln of 3 and then attach the dx. Pero kapag integral ng 3 raised to x, that is 3 raised to x over ln of 3 ha. So naka-divide. So huwag lituhin ang sarili, okay? Ayun. So anyway, going back, ito ang ating du kung ito ang choose natin na u. Pero yung 3 raised to x, wala kasi siya dito eh. So hindi talaga mag-work. Sad face ulit. Hindi usab actually yung attempt natin dito. Yung technique na gagamitin natin ay i-distribute natin si e raised to x dun sa quantity na ito. So, yeah, let's distribute e raised to x over our sum here. So, it becomes e raised to x plus 3 raised to x times e raised to x. And again, the integral, it distributes over a sum. So, pwede nating i-distribute ang integral at magiging ganito na siya. Yung una, is the integral of e raised to x dx. Kayang-kayang ma-integrate mula sa theorem natin, straightforward na agad, e raised to x plus c. Ito yung hindi ganun ka-straightforward. Well, pwede pa nating pagsamahin yung 3 raised to x tsaka e raised to x via loss of exponents. Yung mga base nila ay pwede nating i-multiply and that quantity we raise to x. So again, yung first integral natin ay e raised to x. Straight lang from our formula. And then this becomes plus the integral of, ayun. Bakit natin ginawang ganun? Kasi kapag ganito na siya, naka-form na siya na integral ng b raised to x dx. Where our b here is 3 times e. So gagamitan lang natin yung formula na ito para ma-solve yung integral na ito. So therefore, we get e raised to x plus, using the formula, ang b natin ay 3 times e. So magiging 3 times e raised to x over ln of 3 times e. And then this is an indefinite integral, so don't forget plus c. That is our final answer. Ayun, so may mga examples tayo na nagpapakita na hindi all the time yung substitution ng saving grace natin, no? May mga times na kailangan mo lang i-simplify yung integrand mo. And then from there, kaya na siyang ma-integrate without you sub. So example 8 na tayo. Here we are to integrate this function here. Sige, try natin again like before, u substitution siguro. Ang mga choices natin dito, let's see, pwedeng yung x cubed minus 3x plus 1 na naka-raise sa ating 4. Baka mas maganda yung choice na yun kesa kapag kinuha nyo as u yung x squared minus 1. So kapag nilet u naman kasi itong x squared minus 1, so kayang mental, ang du natin doon 2x dx. Wala dito yung x dx eh. Baka mas magandang gamitin tong x cubed minus dx plus 1. So siguro yun yung gamitin nating u dito. Let's see what the du is. So f prime of x muna, that will be 3x squared minus 3. That whole quantity multiplied to dx. Ang meron lang tayo ay x squared minus 1. But, sana na-realize na factor lang actually ng 3x squared minus 3 ang x squared minus 1. At siya ay magiging x squared minus 1 na lang rito times dx. Where this 3, again, very usual na nakikita na natin kanina, because this is a constant, we can just simply divide this 3 kay du. And so therefore, pag i-rewrite na natin to in terms of u, ma-absorb na lang ng du over 3, itong x squared minus 1 dx. Alright, so yeah, rewrite lang natin in terms of u, siya ay magiging, simple na lang, 4 raised to u, and then x squared minus 1 dx ay absorbed na siya by du over 3. Napasimple natin ang ating integral. And again, itong du over 3 ay just simply 1/3 times du. And from properties ng integral, pwede lang ilabas ang ating 1/3. So this is just 1/3 times the integral of 4 raised to u du. Integral for this, we just use the formula b being 4. We get 1/3 naka-multiply times 4 raised to u over ln of 4. This is again an indefinite integral, so that may plus c pa tayo, do not forget. Okay. And then, like yung ginawa lang natin sa previous examples, pag tayo ay nag-use up, we have to bring back dun sa original natin na variable x yung final answer natin. Okay, so ito ang final answer. Ayun, kayang-kaya. Next. Okay, so ito ang gusto nating i-integrate. We have here e raised to x times cosine of e raised to x over the square root of 1 plus sine of e raised to x. Use up ulit siguro, maybe. Let's try. Well, following from my tip kanina, usual na candidate for u are the inner functions. And yung inner function natin dito ay actually e raised to x. So maybe yun ang ilet u natin. Right? If I let u be e raised to x, then our du is just itself e raised to x multiplied by dx. And actually, si e raised to x dx ay nandito. Circlean ko siya sa ating given. Safe. Yung e raised to x dx ay absorbed lang ng du. Rewriting everything in terms of u, we get cosine of u again over square root ng 1 plus sine u du. Relatively, napasimplify ang ating integral. Pero itong integral na ito, unfortunately, ay medyo hindi pa ganun ka-straightforward i-integrate. Dito, ang magka-come in handy again ay u sub ulit, actually. Pero dito, dahil in terms of u na natin ito, at magsa-substitution tayo ulit, dapat different variable na actually yung gagamitin natin. Ako, ang gagamitin ko na lang ay u prime, maybe. So, sige, tayo ay mag-u sub ulit. Pero ano ang ililet na u natin? If I let cosine u be u prime, du prime is negative sine u du. Wala si negative sine u du dito. Hindi siya factor. So, baka hindi yun yung mag-work. Actually, ang mag-work ay, well, yung denominator natin dito. Yeah. 1 plus sine u. So that our du prime is cosine u du. So, ganun din kapag nagle-let u kayo sa mga iba-ibang types of integrals. Kung may mga naka-add na constants, baka mas maganda kapag in-add na niya yung 1 plus. Kasi anyway, mag-disappear naman siya here. So, yun yung nangyari dito eh. Naging cosine u du pa din siya. Hence, this one, we can rewrite this time in terms of u prime. And that is this one, precisely. Cosine u du absorbed by du prime, and then this is 1 over the square root of u prime. Again, safer to use 1 plus instead of just simply sine u na standalone lang. Yeah, so again, sinabi ko na to kanina, do not be fooled. Huwag niyong square root yung buo na 1 over u prime tapos biglang may ln na nag-appear dyan. No. Rewrite niyo to as a u prime raised to n. So, this one is just rewritten as follows. So, u prime raised to negative 1/2 du. And then, power rule ang gagamitin natin dito. No? So, using the power rule, we get u prime raised to 1/2 over 1/2. So, there, ito na actually yung final answer natin. Hindi pa. Almost final answer. You just have to bring back the original expression for u prime. But take note, si u prime ay yung second level na or second time na substitution natin. Kaya once we bring back, siguro isa-isahin na lang natin. You bring back the definition for u in terms of u first. And then after that, bring back yung definition for x, which is what you want. So yeah, doing that, anong nangyari dito? Naka-divide kasi by 1/2, so minultiply siya by 2. Yung power na raised to 1/2 ay ginawa ulit na square root. And then yung u prime, binalik siya in terms of its definition in u, which is 1 plus sine u. And one last step, ang original variable natin ay x. So you have to bring back your definition for u in terms of x. And so, ito ang final answer natin. 2 times the square root of 1 plus sine e raised to x plus. Okay, so nasagutan na natin. Hooray! May babanggitin lang ako dito kay example 9, very quickly lang. There's an alternative solution actually kasi dito medyo mahaba in the sense na twice tayo nag-substitution, which is completely fine. Kung dito kayo mas sanay, dito kayo mas comfy, it's okay. Pero papakita ko rin that there's a slightly more short solution sa pag-solve nito. Pwedeng nilet union na agad yung 1 plus sine e raised to x. Ang derivative ng sine e raised to x, kailangan lang mag-chain rule for differentiation. So, cosine e raised to x siya times the derivative of the inner function. The inner function is e raised to x, the derivative of that is just itself. Kaya may times e raised to x ka dito. Don't forget, naka-multiply si differential of x dx. Na, ito precisely is our numerator actually. So, yeah, rewrite lang natin yung integral using this new definition for u, alternative definition for u. Ayan, so naging integral lang siya ng 1 over square root of u. This absorbed by du already, and it simply became 1 over square root of u. Na alam na natin paano i-integrate, transform lang natin to be u raised to n. Using the power rule, we get this as our integral. U raised to 1/2 over 1/2 plus c. And then the final answer, for the final answer, you just bring back your expression for u. And see, we got the same answer. Ito rin yung answer dun sa previous slide. So, ayun, there's an alternative solution. Pinakita ko lang na mas ma-short. Pero baka kasi hindi to yung mas natural sa inyo, na okay lang naman. Either long cut or shortcut, both naman nag-arrive sa same correct answer. So, kayo na bahala dun. No? So, pinakita ko lang. Okay. Last na tayo. Hooray! Last example for this lecture. So, evaluate natin ang definite integral. Ito, definite integral. So, kung may mga u sub tayo dito, we also have to change the bounds. And this is our integral. Sige, ano kaya ang pwedeng u dito? Try natin i-predict kapag nilet u natin ang e raised to x plus 1, what is our du then? Ang du natin ay e raised to x then, tapos times dx. The plus 1 just vanishes. The next question is this e raised to x dx na factor found here in our integrand? Kasi if so, then ma-absorb lang siya ni du at masisimplify. Sa ating numerator, actually, there's a common factor of e raised to x that we can factor out dun sa expression sa numerator. And pag na-factor out na natin yung e raised to x na yun, pwede natin siyang i-combine kay dx and then that will be absorbed by du already. I-factor out ko yung common factor na e raised to x dito so that I can make it appear and use that for my du. Siya ay magiging e raised to x. And then, pag divide ang e raised to x sa sarili niya, then that will just be 1. E raised to x dx absorbed by du. Yung e raised to x plus 1 ay simple. Siya ay magiging u lang rin, no? Pero paano yung e raised to x minus 1? Well, again, take note nyo lang na ang goal kasi natin ay ma-rewrite si integrand in terms of u. So, lahat dapat ay in terms of u, whatever the expressions there are. Kung ito ang ating definition for u, kaya naman nating ma-rewrite ang e raised to x minus 1 in terms of u. So, parang pwede nyo isipin, kung ang u ay equal sa e raised to x plus 1, then ang e raised to x lang ay equal sa u minus 1. So, therefore, furthermore, ang e raised to x minus 1, dito sa right-hand side, paano siya mapupunta dito kay e raised to x minus 1? Subtract lang tayo ng 2. So therefore, ang left-hand side yung minus 2. At ma-rewrite na natin itong expression na to in terms of u as u minus 2. Again, ang nilet u natin dito ay yung denominator, e raised to x plus 1. Where the 1 vanishes because it is just a constant, and then the derivative of e raised to x is just e raised to x. No? And then multiply that to the differential of x. Again, we forced e raised to x dx to appear. How? By factoring out e raised to x sa ating numerator. So, matitira yung e raised to x minus 1 na expression sa numerator na at first, seemingly, paano natin i-express as u? Pero kinaya naman natin through translation. And again, inulit ko lang dito, if u is equal to e raised to x plus 1, to get the expression in terms of u ng e raised to x minus 1, subtract ka lang ng negative 2 both sides ng equation. So you get u minus 2 as the expression for this one in terms of u. Just don't forget, again, the bounds you have to change in terms of u. So, ang lower bound nito in x ay 0. If ito ang definition natin for u, then we get e raised to 0 plus 1 equal to 2. And then, ang upper bound natin in x is ln of 2. So, rewriting it using u, we have e raised to ln 2 plus 1 or 3. Okay. Hence, rewriting our integral here in terms, everything in terms of u, we simply get this. Bakit ulit? Yung 0 naging 2, yung ln2 naging 3, yung e raised to x dx absorbed by du, yung denominator na e raised to x plus 1 ay si u na definition natin, and si e raised to x minus 1 nakuha as u minus 2 via translation. Dapat alam na sana by now, hindi tayo mag-u-sub na ulit dito. Okay? This is just like example 1 na Pag meron kang sums or differences sa iyong numerator, pwedeng i-distribute ang denominator mo among each of the terms of your numerator. So let's do that. Ayan. So u over u minus 2 over u. Ang u over u ay just equal to 1. Integrate na natin to. Integral ng 1 ay u. Integral na negative 2 over u. Yung negative 2 ay lalabas lamang. And then integral ng 1 over u dio, something that we should know already, ln absolute value of u yun. Nag-multiply c minus 2. And we evaluate that from 2 to 3. So pasok lang natin si 3 muna, upper bound muna tayo into our function. 3 minus 2 ln of 3, pwedeng i-do away na yung absolute value kasi positive naman si 3. And then the formula goes minus, okay, yung function mo nang nakasubstitute naman yung lower bound. So that is 2 minus 2 ln 2. And so your final answer is this 1. 1 minus 2 ln 3 plus 2 ln 2. Actually, that's it. So yung last slide ay mga discussion exercises. Hope you learned something from me. Thank you very much for watching and see you next time. Bye!